Let's determine the general solution of this differential equation. Basically, this differential equation is second order non-homogeneous differential equation with constant coefficients. So it is second order non-homogeneous differential equation with constant quotient. We say that it is non-homogeneous because if you look at the right side of this differential equation, we have this expression 2e power minus t. If only if it was 0, we say that it is homogeneous differential equation. So let's see how to determine the general solution using the method of undetermined coefficients. In this method, that is the method of undetermined coefficients, we say that the general solution can be written as this is y general and this equals yh plus yp, where yh is the homogeneous solution and yp represents the particular solution. So first we have to calculate the homogeneous solution, and then we calculate the particular solution, and then we add them together, which gives the general solution of this differential equation. So first let me form the homogeneous equation using the given differential equation. So for that we just have to consider only the right side expression and then equate to 0. So I'm going to write down this homogeneous, we are finding the homogeneous solution. So here we consider only the right side expression, that is y double prime plus 2y prime plus y, and this equals 0. Now we can write down its characteristic equation. Remember that in characteristic equation we replace y double prime by r squared and y prime by r, so it becomes 2r plus y will become 1. So this equals 0. Now we can solve for r using this equation. This is basically a quadratic equation, and we can write down this as square of the binomial, that is r plus 1 quantity square, and this equals 0. This is equal to r plus 1 times r plus 1 equals 0. So here we get two roots, that is r equals negative 1 as plus negative 1. So we see that it's a case of r equals negative 1, and this repeats. We can write down this as repeats like twice. So we can say that the solution to this equation is, suppose if r is repeating, let's say r. Since it repeats, we don't have r1 and r1, it's just r. Then we write down the solution, that is the homogeneous solution, and this equals a e power rt plus bt e power rt. So we can use this formula. I'm going to write down the characteristics, the homogeneous solution of this equation. So we write the homogeneous solution, and this equals a e power, we replace r by negative 1, so it becomes r times, that is negative 1 times of t is negative t plus bt e power r times t. R is negative 1, so t times negative 1 is negative t. So this equation basically represents the homogeneous solution of the given differential equation. We will now see how to determine the particular solution of this differential equation. So for this, I'm going to make a guess for the differential for the particular solution. So by looking at this right side expression, so the right side expression we have 2e power negative t. So we can make a guess like this is in the form of this is c e power negative t. But we have to be a little bit careful here, because if we use this c e power negative t, we already have this in the homogeneous solution. That is, we have a e power negative t. So I can now multiply this by t. So when I do that, I get ct e power negative t. But also we have to look at this homogeneous, and once again we have the same form, that is bt e power negative t. So we cannot have this form, and we have to multiply by one more t again. So therefore this becomes c times of t square e power negative t. So this is the guess that we are making. So we can consider this particular solution is in the form of c t squared e power negative t. Now we have to differentiate this yp. So let's do the differentiation. We will get yp prime, and this equals, here we can use the product rule, considering this expression as first, and then the e power negative t as the second expression. So first I differentiate the first expression. This will be ct square. If you differentiate using the power rule, we get c times of differentiation of t square is 2t. So this basically is 2ct. So I put the 2ct first, and then multiply with the second expression as it is, that is e raised to the power of negative t. Plus, now we keep the first expression as it is, that is ct square, and then multiply with the derivative of second expression. The second expression is e raised to the power of negativity, and when we differentiate this, we'll get negative of e power negativity. That is, by applying the chain rule, we get this negative. So I can put negative e power negative t. This is the derivative of e power negative t. Let's simplify this. So we have yp prime. This equals 2ct e power negative t, and the second term is a negative, so I put this negative of ct square e power negative t. Let's continue, and we'll do one more differentiation. So this is c, so is, t squared. So let's find the derivative of this expression. That is, we will get y p double prime. So let's differentiate the first expression. So here I'm going to consider this 2ct as first, and then e raised to the power of negative t as the second expression. So when we find the derivative of 2ct, we get 2c is a constant and derivative of t is 1. So basically we get 2c. So I put 2c and then multiply with the second expression, that is e raised to the power of negative t. Then I consider plus 2ct, that is I keep the first expression as it is, multiply with the derivative of e power negative t. We already figured out that derivative of e power negative t is negative e power negative t. So these two has to be multiplied, and then we have to find the derivative of the next expression, that is ct square e power negative t. If we look at this yp prime, this is exactly the same expression, that is ct square e power negative t. So therefore, its derivative is the expression that we already got. So I'm going to replace this expression and substitute here for the derivative of the ct square e power negative t. So we already have a negative here, that is this negative. So I put this negative and then put the bracket, and then write down these two terms. That is these two terms in this expression. The first term is 2ct e power negative t. So I write down 2ct e power negative t. And then the second expression is negative ct square e power negative t. So this is negative ct square e power negative t. Now let's simplify this. So we have y double prime of p. This equals 2c e power negative t, and this is 2ct. We have a negative here, so it will be negative of 2ct e power negative t, and this we will distribute this negative inside the two terms, so it will become negative 2ct e power negative t, and negative times negative is positive, so this becomes positive ct square e power negative t. Let's see if we can combine any like terms and put it in a more simplified form. That is yp double prime, and this equals, we have a like terms here, that is negative 2ct e power negative t, and then one more negative 2ct e power negative t. So this is nothing but negative 4ct e power negative t. So I write the first term as it is, that is 2c e power negative t, negative of 4ct e power negative t plus ct square e power negative t. Now all that we do is we take this two derivatives as well as the yp, that is we take this second derivative that we have found as well as the first derivative as well as the yp equation, and put it into this original differential equation. So I'm going to rewrite this original equation by including the particular form, that is we will get, and so it will be yp double prime plus 2yp prime plus yp, this equals 2 e power negative t. So this is the original differential equation uh, written with a particular form. Let's substitute this yp double prime, yp prime, and yp over here. So first let me substitute the yp double prime, which is 2c e power negative t minus 4ct e power negative t plus ct square e power negative t. Then I put plus, we need to multiply the yp prime by 2. So we have this yp prime. The first term here is 2ct e power negative t. So if I multiply by 2, we'll get 4ct e power negative t. So I put 4ct e power negative t. And then the second term of yp prime is negative ct square e power negative t. So if you multiply by 2, we get negative 2ct square. We get negative 2ct square e power negative t. And then we have to finally put the yp. So we have yp equals ct square e power negative t. So I put ct square e power negative t, and this equals, on the right side we have this expression 2 e power negative t. So we have to simplify the left side expression and solve for the variable c. That is our focus. So let's look out for some like terms, group them, and simplify them. We have negative 4ct e power negative t, and this one 4ct e power negative t. This is positive and negative, so they cancel out each other. And also we can combine these like terms, that is we have ct square e power negative t and one more ct square e power negative t, which gives 2ct square e power negative t, and we already have this negative 2ct square e power negative t. So when we add these three terms, they become 0. That is 2ct square e power negative t minus 2ct square e power negative t. So they become 0. So finally we are left with the expression on the right left as 2c e power negative t. And this equals, on the right side we have 2 e power negative t. We divide both sides by 2, so they become cancelled. And we can also cancel out this e power negative t. That is, we divide both sides by e power negative t. So on the right side we just have 1, and on the left side we have c. So therefore this gives c equals 1. So we have determined the value of c, and this means we have found the particular solution. So we put back into the particular form which we already figured out. So we are going to get the particular solution, that is yp equals ct square, that is 1 times of t squared e power negative t. So this is basically equivalent to yp equals t square e power negative t. So we have found the particular solution of this given differential equation. Now that we have both the homogeneous solution as well as the particular solution, we already said that the general solution of this differential equation using this method is yh plus yp. YH is the homogeneous solution and YP is the particular solution. So therefore, we say that YG, which represents the general solution of this differential equation, and this equals YH. I replace for YH, which is AE power negative T plus BT e power negative T plus now I replace YP, which is T square e power negative t. In fact, this can be written in simplified form or in factored form when can factor out the e power negative t. So when we do that, we get a plus bt plus t square times e power negative t. Or in fact, we can also write down in another factor form, that is yg. This is yg, and this equals a plus I factor t from these two terms. If I factor t from these two terms, I will be getting t times of b plus t. This is multiplied, and we also have one more bracket to multiply with e power negative t. So basically, this represents the general solution of the given differential equation. You can consider either this form or this form.